Good afternoon, good morning, hello scholars. Welcome to our Read Aloud. So today we're going to be reading a different book about global warming by this author, Seymour Simon. So he's an interesting author because he also writes nonfiction books, but he does them in a bit of a different way with many beautiful photographs, as you can see here with these polar bears, but with less text features. So we're going to be getting similar information to our last book on global warming, but in a bit of a different way. So I'm just going to go down here so you can get a better view. Global warming. So here I can see some extreme weather. Thousands of years ago, large parts of the landmass on Earth were covered by ice. The end of this ice age occurred about 11,000 years ago. Since then, Earth has been getting warmer. In recent decades, the rise in average temperature has been particularly rapid or really fast. Global warming is the term that has been used to describe these changes. Weather and climate are different, which hopefully we already know. Weather is what happens every day. Climate is the average weather over a period of years. So that's similar to what we learned in our last book. For example, it's possible that the weather on any day might be cool, but the average weather, the climate, is getting warmer. Why is the climate changing? Could Earth be getting warmer by itself? Are people doing things that make the climate warmer? What will be the impact of global warming? Can we do anything about it? So even though there aren't any text features like there is in a table of contents, Seymour Simon is giving us a preview here with these questions about what he's going to talk about. And maybe we know the answers from our last book, but maybe we don't. Or maybe we're not sure. Let's have a look. Global warming is happening because of the greenhouse effect. I remember this from our vocabulary, and I also remember this from our last book. A greenhouse is a house made of glass. The glass lets in sunlight but keeps warm air from escaping. Earth is not a greenhouse, but certain gases in the atmosphere act like the glass in a greenhouse. Sunlight passes through Earth's atmosphere and warms the ground. Some of the heat bounces back into space, but much of it remains trapped near the ground by carbon dioxide, water vapor, and other greenhouse gases in the atmosphere. The greenhouse effect helps make Earth warm enough for life to exist. We also learned a little bit about that last time. But if greenhouse gases are released into the atmosphere in larger amounts, much faster than before, then the warming will get much stronger and the climate will noticeably change. So some greenhouse gases are good, but too many too fast is not good for us. And there is our Earth with the atmosphere. You can see some of the gases moving. In 2007, a report by 2,500 scientists from 130 countries concluded that humans are responsible for much of the current warming. No one person causes global warming, so it's not your fault or my fault. But there are billions of people on Earth. We cut down huge numbers of trees, drive hundreds of millions of cars and trucks, and burn vast amounts of coal and oil. All these activities contribute to a huge increase in greenhouse gases. Even if we decrease the amount of gases we now produce, it would not immediately stop the warming because greenhouse gases stay in the atmosphere for years. The Earth's climate is very complex or complicated or hard to understand, and many factors play important roles in determining how the climate changes. Natural variations in Earth's orbit around the sun change the amount of sunlight we receive and thus the temperature. Earth has had much warmer and much colder climates in the distant past. Most scientists agree that something different is happening now. While Earth's climate has always varied, it is now changing more rapidly than in any other time in recent centuries. Since we have been keeping weather records, 19 of the 20 hottest years ever have happened since 1980. So, this is giving us some evidence about how we can really prove and show that the Earth's climate is getting warmer and warmer. And here we have a smokestack. For thousands of years, the balance of greenhouse gases in the atmosphere had not changed much. But now we burn huge amounts of coal, oil, and natural gas to generate energy like electricity, which we talked about before. Every year, billions of tons of carbon dioxide pour out from the exhausts of cars, trains, trucks, airplanes, buses, and ships, and from the chimneys of factories. I wonder how many of us use cars or trains or airplanes or buses, or even trucks or ships. Think about the last time that you were in a car or a train or a plane or a bus. And all of this is putting out carbon dioxide into the air. There is 30% more carbon dioxide in the air than there was 150 years ago. Trees, like other green plants, convert carbon dioxide into oxygen. But trees and forests are cut down in huge numbers. We remember this means deforestation, right? When complete forests are cut down. When wood burns or decays, even more carbon dioxide is released. Carbon dioxide enters into the atmosphere much faster than the remaining forests, and oceans can absorb it. The release of other greenhouse gases adds to the speed at which the world's climate is changing. Methane is released by millions and millions of cattle and other farm animals. Nitrous oxide comes from chemicals used in soil fertilizers as well as from automobiles. And here we can see this is some bad air, like some pollution. So here there's the carbon dioxide going in the air and it's causing the pollution. The Arctic is already showing the effects of global warming. Average temperatures in the northern regions of Alaska, Canada, and Russia have risen twice as fast as in the rest of the world. The Ward Hunt Ice Shelf, the largest single sheet of ice in the Arctic, has been around for 3,000 years. It started to crack in 2000. By 2002, it had split. Now it is breaking into smaller pieces. The Arctic Ocean is the great body of sea ice that covers the North Pole. Satellite photographs show that the ice pack has been shrinking and thinning in depth since the early 1900s. Scientists say that for the first time in human history, ice may disappear from the Arctic Ocean every summer. This is really sad. And you can see the ice is melting. Global warming has also changed the feeding patterns and behaviors of polar bears, walruses, seals, and whales. It may even impact their survival. Polar bears live only in the Arctic. They are completely dependent on the sea ice for all their life needs. In the winter, females give birth to cubs. The mother polar bear eats little or no food during the winter. As spring approaches, the bear family makes a run onto the sea ice to feed on seals, their main source of food. If the ice melts, their food supply will be cut off, and this will impact their survival. We talked about this a little bit in our last book as well, how if the ice melts, it's going to affect many animals, not just polar bears, not just seals, right? Glaciers and mountain snow covers are rapidly melting. Almost every glacier in Alaska is receding, means getting smaller. A few decades ago, huge rivers of ice stretched over the land. Now, hundreds of feet or sometimes miles of bare rock and soil are exposed. In 1963, the Mendenhall Glacier Visitor Center in Juneau opened, very close to the glacier. Today, it is a mile or more away from the frozen edge of the retreating glacier. In the 1850s, there were 150 glaciers in Montana. By 1968, there were 37. In 2008, there were fewer than 24. Glaciers that have lasted for thousands of years may be gone in 2 decades, that's 20 years. The icy coverings on tall mountain peaks are also disappearing. Each year, there is less snow remaining on the mountains during the summer. The snow melts earlier by a week or more in the spring, and snow falls later by a week or more in the autumn. So snow is melting faster and there's even less snow. This is a glacier in 1957. You can see there's a huge big piece of ice here. And then in 2004, this is what happened to the glacier. So 1957, 2004. As temperatures rise, the level of the oceans will rise. A recent study found that if average temperatures rise by 3 degrees Celsius, Greenland's enormous ice sheet will begin to melt, and sea levels all over the world may rise by half a foot to 3 feet or more. This may happen over years or decades, or may take longer than a century. A 3-foot rise in sea level would swamp the Gulf Coast and every East Coast city from Boston to Miami. Rising waters would cover low-lying areas such as the Nile Delta and countries such as Bangladesh. Millions of people would be forced to move. So this is a flood when the water gets too high, and they're saying that's what can happen if temperatures continue to rise. The Antarctic ice cap holds about 90% of the world's ice and about 70% of its fresh water. It does not look as if the entire ice cap will melt anytime soon, but if that does happen, sea levels would rise 20 or more feet. Now that would cause major flooding in coastal areas. So 20 or more feet is like 3 or 4 of how tall Mr. Gassner is. So that's a lot of water. Atmospheric warming can cause a rise in ocean's temperatures and place coral reefs in jeopardy. Coral reefs are huge branching structures made of the limestone skeletons of tiny animals called coral polyps. Coral reefs are found in warm, clear, shallow oceans. Sometimes you can snorkel or scuba and you can see coral reefs. They are home to many kinds of fishes, jellyfish, anemones, crabs, turtles, sea snakes, clams, and octopuses, and the algae that give the reefs their stunning colors. Most coral reefs are highly sensitive. Even small changes in water temperature and in the amount of carbon dioxide in the water can kill algae in a reef. When the coral dies, it bleaches white. In 1998, a weather pattern called El Niño warmed the seas. In just 1 year, about one in every 6 of the world's reefs was lost. If coral reefs die, then much of the animal life they support will be wiped out as well. So this is like a live coral reef, and you can see there's a lot of little animals floating around. They eat it, kind of like Nemo and Dory. But if the coral reef dies, it turns white, and then no other animals can really go there to eat or to hide or things like that. Changing climate affects every ocean and every continent. Rising temperatures add heat energy and water vapor to the atmosphere. That can lead to heavier rainfalls and more powerful storms in some places and long droughts in others. The changes will differ depending upon the location. So this is kind of talking about the extreme weathers that can happen as well. Many tropical areas may have greater rainfall, but in dry regions, even less rain may fall. Higher temperatures will cause the soil to dry up, and terrible droughts may ensue. This is kind of like a drought when the ground is like way too dry. Wildfires may increase in forested areas as timberlands grow drier. The fires are likely to be bigger and more frequent and to burn longer. They would also release more carbon dioxide into the atmosphere and could lead to more warming. A wildfire is kind of like what was happening in Australia for a while, how it kept burning and it was really hard. It's really hard to control or to stop those fires. Climate changes are not as easy to notice as changes in the weather. For example, a particular storm or a number of warm days during a winter is not really evidence of anything. We can all see day-to-day weather changes, but climate changes are noticeable as well. Plants and animals are already showing the effects of Earth's warming. Cold places, such as the North and South Poles and mountaintops, have been the first to feel the heat. Spring has come earlier, the ice had melted sooner, and there are fewer days where the temperatures are below freezing. Many kinds of wildlife need the cold to survive. Some animals have adapted to the warmer weather by migrating to colder places. As the climate has warmed over the past century, the colorful checker spot butterfly of the American West has moved northward or to higher elevations. This is that butterfly. The checker spot butterfly has almost completely disappeared from its original home in Mexico and has adjusted to its new northern home in Canada. But not every animal can travel as easily. Scientists worry that crowding on mountaintops and colder places will cause some species to become extinct. And there's a better photo of the checker spot butterfly. I remember these wind turbines and solar panels. So we can't do anything about some changes in our environment. Our planet may be going through a natural cycle of getting warmer. However, most scientists say that humans are at least partly responsible for climate change. This means it may be possible for people to slow down the change. There is a debate about what we can do about our changing climate. Here's what people in some nations are trying to do in some different countries. Improve fuel and energy economy so that people use less energy for vehicles, schools, offices, homes, and factories. Encourage the use of wind and solar power. Wind and solar. Explore alternative ways of producing energies that do not directly release more greenhouse gases into the atmosphere. Protect and plant trees to increase forest lands. That's a good one. I think that's very important. And let me just go to the last section. So nations and governments can do certain things to slow down dramatic climate changes. People can help too. They can choose to use less energy to heat and cool their houses or use less fuel when getting around. Here are some things we might consider. So these are things that we can do too. So walking, biking, or use like public transportation. One school bus can carry the same number of children as 30 or more cars. Using sturdy, reusable bags for shopping and reusable cups and glasses is less wasteful than using disposable bags and cups. So I always bring my own bag when I go to the store and I don't use any plastic bags. Taking short showers uses less energy than long showers. Planting a single tree can make enough oxygen for the lifetimes of 2 people. If 1 million trees are planted, the trees would eventually absorb more than 1 million tons of carbon dioxide. So that's what I was saying, planting trees is really important as well. Here's what some families are doing to slow down rapid climate change. Using fans instead of air conditioners. There's some details about that. Using energy-saving fluorescent light bulbs instead of incandescent light bulbs. Turning off electric appliances and lights when they are not being used. Mr. Gassner always makes sure we turn off the lights. Installing double-paned windows, extra insulation, good weather stripping, and solar panels to houses also saves energy. Global warming isn't just about the Arctic Ocean melting and distant deserts becoming drier and hotter. Climate change impacts all of us. It can affect the world's food supply and the economic stability of countries. The people and the governments of the world are developing the tools and the scientific know how to meet these challenges. As Earth's climate continues to change, we all want to find ways to safeguard our own and future generations. The end. So I just want to kind of go back and in closing, think about a lot of the different strategies that some people are using to slow down climate change. Turning off lights, not using plastic, using public transportation like the train instead of driving. So what are some little changes that you think you might do also? Okay. And you're going to answer some of these questions next. Thanks for watching.